Good day to you. This is LELAND. We're going to start with proving statements which can be used in geometry and algebra. Now we're going to start with the properties from algebra, which will be used in the proving. Now we're going to study two-column proofs. And let's begin with the properties of equality. And we shall see that in this particular screen, which comes from the book. Okay, so we have over here, the following properties are true for all real numbers A, B, C, and D. And under properties of equality, the first one is the addition property. If A equals B, then a third quantity C added to A must be equal to the C added to B. So A plus C is also equal to B plus C. Under subtraction property, we have if A equals B, then the amount C subtracted from A is equal to the amount C subtracted from B. So you can see the subtraction property over here. So if you have the quantities A equal to B, subtracting the same amount C from both sides will still be equals. You can also see these like equals subtracting or subtracted from equals will still be equals. And same thing if you go back to addition. If you add equal amounts to equal amounts, the sum will also be equal amounts. So the third is multiplication property. If A equals B and you have another quantity C, multiplying C by A must be equal to multiplying C by B. So CA or C times A is equal to C times B. That's multiplication property. The division property is if A equals B and you have a third quantity C which should not be equal to 0, then quantity A divided by C is also equal to quantity B divided by C. C not equal to 0 because we cannot divide by 0. That is not allowed in math. The next one is the distributive property, which you can find right here. A times the quantity B plus C is equal to the product of A and B plus the product of A and C. So you simply distribute the A to the first term B and the A quantity to the second term C. And that's the distributive property. Next one is the substitution property. If A plus B is equal to C and B is equal to D, then the next statement is true. A plus D is equal to C. You will notice the first statement is A plus B equal to C, and B set to D means D can occupy or substitute in this place here. Or you can substitute the D in place of B anywhere you find B. That's why you have A plus D equals C also. That's also true. So it's substitution property. Now reflexive property, that's A equals A. Reflexive meaning any quantity is equal to itself. It's like looking at the mirror. Anything you place at the mirror, all right, reflects itself. So that's why you call this A equals to A. So that's reflexive property. Any quantity is equivalent to itself. Then we go to the next one, symmetric property. If A equals B, then B equals A. So you can shift left to right to left. Yeah, that's a symmetric property. So be able to differentiate substitution from symmetric. Okay, symmetric. Symmetric is more on commutative. A equals B, then B equals A. Transitive property is like a connection. If A equals B and B equals C, then A equals C. That's the transitive property of equality. So we're going to be using this property in proving algebraic statements first. And then we'll go to geometry, which will include figures, diagrams, and definitions, postulates, theorems. Now, those are the statements that we'll be using in geometry. In algebraic proving, we will be using these properties of equality that we just discussed. All right, so we can begin with the examples or lecture examples, and we shall find it in the other screen. So let's get that screen first. All right, let me check on the given here. There should be an equivalent of that over here. There, all right. We shall see it one by one. Okay, here's the first one. If 2 times the quantity 5x minus 3 is equal to 8 plus 3x, then we shall prove x equals 2. All right, this is algebraic, okay? And the given hypothesis is 2 times 5x minus 3 equals 8 plus 3x. Now the conclusion that is to be proven, x equals 2. Now we're going to have the solution in the other screen. All right, so we should get the other screen at this point, and we shall get the first problem. All right, let me check on the problem over here. And we shall copy that particular number 1 problem, copy and paste only, and then we shall be able to go back to that screen that we're going to use. Okay, it must be this one. Okay, so this should be it. This is for the first number. This must be 1. There. Now, if, I hope it's large enough for you to see it. If 2 times the quantity 5x minus 3 equals 8 plus 3x, then prove x equals 2. There. We are going to prove this given this particular equation. Now, the solution that we're going to use will be involving statements, and of course, that will be for the first column. The other column will be the reasons. There. Okay, so to start with this one, our first statement will be the equation. Okay, it will be like just this part over here. 2 times the quantity 5x minus 3 equals 8 plus 3x. And the reason here is just given. There, that's our first statement. For our second statement, we shall be able to simplify this part by way of distributive property, by distributing the 2 to the 5x and the negative 3, and then we will call this distributive property. So for the second line, we're going to have 2 times 5x, that should be 10x, and then 2 times negative 3, or that would be minus 2 times 3, so that will just be a 6. And is equal to the right side 8 plus 3x. And this must be called distributive property. There, those are the statements and reasons for the first and second lines of our solution. This is how to prove it. And then it continues to the next line. Now, our objective here, or our plan, is to come up with the solution and see and find out if it will give us x equals 2. So at this point, we can actually try subtracting 3x so that we will be able to have just one term x here. So we will have here 10x minus 6, and then we shall apply subtraction. Minus 3x equals 8 plus 3x minus 3x. There. And we will call this, of course, subtraction property. There. Next, we have 10x minus 3x. That should be combining like terms, which will give us 7x. Minus 6 is still there. And the right side, it will just be 8. Because this 3x gives a 0. Now, you can call this just combining like terms or simply simplification. So this will now be just combining like terms or simplification. And then for the next line, we shall try to eliminate the 6 there by way of addition. And we're going to have 7x minus 6. And then we add 6, and this equates to 8, also plus 6. Yeah, and we will call this addition property, of course. So you see we're having 2 columns here, which is actually the 2-column proofs, okay, the top-down version. And we have 1 column for statements and another column for the reasons. And at this point, we're going to have the next line. That should be about just 7x equals to 14. And again, you can just call this a simplification. And then on line 7, we shall try to divide this. So we're going to have 7x, you divide this by 7, and equals 14, you divide this by 7. And we will call this division property. Division property of equality. And the next line will just be x equal to 2, which gives us the proof. So this is by way of simplification there. So this is how to prove a given argument with a given conclusion. So these are the statements and these are the reasons. Now we shall be doing the next number, and that will be for number 2. Okay, so let's get on with that screen again, and we shall be able to see. So this is the way to do proving with a 2-column procedure. We have statements and reasons. Now, before you can do something like this, you have to know those things that we have read: distributive property, subtraction property, addition property, division property, and all the others like reflexive, symmetric, transitive. That's why we have to discuss those properties of equality first. So let's see another problem again, and then we shall go back to the problem set. Okay, so we're done with number 1, first number. Let's have the second number. Here's the second. If 7 equals 2x minus 5, prove x equals 6. Okay, so we shall get that in the screen that we have obtained a while ago. So it must be this one. We'll just copy and paste over the other screen. All right, let's go back to our working screen. And that will be over here. Okay, now we shall remove this part here and work on the second. This is now number 2. And here is the next one. If 7 equals 2x minus 5, prove x equals 6. Again, we're going to do the solution by using statements and reasons using two columns. So we have here the statements and we have the reasons in the second column. There. So for the first statement, it should be the given. It should just be the given. All right, let me just do a little adjustment there. Okay, here's our given. If 7 equals 2x minus 5, prove x equals 6. Now, the given is 7 equals 2x minus 5. There. Now, the reason for the first statement is just a given data. So it will just be written this way. For the second, you shall try to isolate right away the x term by way of adding 5 to both sides. So we'll be using addition property here. So we're going to have like 7 plus 5 equals 2x minus 5, and we have to add 5 here. And this will be called, of course, the reason here will be addition property. There. And we're going to end up with 12 equals 2x. And this is just by way of simplification or combining like terms. So you can write there combining like terms or simplification. Like that. And then for the next line, you apply, of course, division. So you divide the left side by 2. And you have the right side also divided by 2. And of course, the reason for this is division property of equality. There. And then the next line will give us 6 equals x. And that's by simplification. And then the next line, we don't usually write 6 equals x. So this must be written x equals 6. And this is by the reason symmetric property. There. And it's now proven. There. So this is the way to do it using two-column proofs. And we shall continue with the third example. All right, so let's get the other example, and that should be over here. We're now doing the third. Okay, if 1 is equal to 3 times the quantity x plus 8 over 3 minus 1, prove x equals negative 2. So this is for number 3 example. So we're given a statement again, the hypothesis. The conclusion is x equals negative 2. We have to prove that the value of x in the equation is negative 2. So we shall get this problem and copy in our work area. This is our third. All right, let us get this to our screen, and that will be over here. Okay, here is still number 2, so we shall just delete this number 2, and we shall write the third example there. Okay, if 1 is equal to 3 times the quantity x plus 8 over 3, close parentheses minus 1, then prove x equals negative 2. Again, our solution is by the top-down version with two-column statements and reasons. So we shall have statements and reasons there. For the first statement, we will just have to write our given hypothesis. So this is 1 is equal to 3 times the quantity x plus 8 over 3 minus 1. That's the given. So our reason statement will just be given given data. All right. Now, what we can do here is to eliminate this number 1 here by way of addition. Add 1 to both sides. So we're going to have addition property. We add 1 was 3 times the quantity x plus 8 over 3. And we still have that minus 1 there. And we shall apply addition of 1 there. So our statement reason is addition property of equality there. And then this becomes, of course, 2 equals the same 3x plus 8 over 3. And that minus 1 plus 1 gives 0. And this is just by way of combining like terms. Or simplification. There. Next, we now have 2 equals 3 times the quantity x plus 8 over 3. We shall manipulate the right side by way of distributive property. So this will be 2. This is equal to 3x, and we have plus 3 times the quantity 8 over 3. There. And this will be a distributive property. So we're going to write the reason for this one, distributive. Let me check the spelling. It's distributive property. Yeah. Okay. So by way of simplification, we will be having just 3x. And you see this number 3 cancels out with the 3. So this will be left just 8 there. And we shall be able to isolate the 8 so that we will only have the x term on one side. So this is by way of simplification. And for the next line, we will apply subtraction property. 2 minus 8 is equal to 3x plus 8, and then minus 8. There. And this is now subtraction property. There. And this gives us negative 6 equals 3x. That's combining like terms. And for the next line, we're going to have here negative 6 divided by 3. So negative 6 we divide by 3 is equal to 3x divided also by 3. And we call this division property. There. And for the next line, this will divide or simplify to negative 2 equals x. And this is simplification. And of course, our last line is x equals negative 2. And the reason for writing it this way is the symmetric property. There. If you remember symmetric property, if A is equal to B, then B is equal to A. So in this case, in number 9, you have if negative 2 equals x, then we shall be able to write that, then x equals negative 2, which is the required conclusion. So at this point, it's already proven. Okay. And that will be for our example number 3. We shall have 2 more examples. All right, and we shall get that from the other screen, and we shall be able to see that. Number 4. If negative 6 equals 2 times the quantity x plus 2, prove x equals negative 5. This is our 4th example. If negative 6 equals 2 times the quantity x plus 2, then prove x equals negative 5. All right, we shall copy this problem to the other screen where we're doing our work. And that will come here. We're doing number 4. Okay, so we shall just copy this part. That's number 4. All right, and we shall go back to our working screen. That should be all right. It should be the word, okay, and that might be somewhere over here. Okay, yeah, found it. All right, we shall erase the previous, which is the third. We shall erase this part. Okay, we shall just erase it, and this will be the fourth, and we paste that. Okay, here is our number 4 example. If negative 6 equals 2 times the quantity x plus 2, then prove x equals negative 5. Again, we're doing the two-column proofs, or two-column proving, which involves statements and reasons. All right. There. All right. First statement, we simply get our given, negative 6 equals 2 times the quantity x plus 2. There. And the reason here is just given data there. Second, we shall try to do either we distribute, okay, we can do distributive property and then simplify and then divide, and that's it. You can also divide here, okay, and come up with the answer. Okay, so we shall try the distribute, all right? Anyway, the numbers are just small. So you have 2x and a 4. And we can call this distributive property. There. And then we shall isolate the term with the x, and therefore we shall eliminate the 4 at the right side by way of subtraction. So we have negative 6, we subtract 4, and then we have 2x plus 4, we subtract 4. And we will call this, and the reason is subtraction property. There. So negative 6 and negative 4 is a negative 10, giving us the left side, and the right side is just 2x. And this is by way of combining like terms. Or you can call this simplification. There. And then the next statement we can use is, of course, divide by 2. So we have negative 10, we shall divide by 2, both sides of the equation. And this we call division property. There. And this results to negative 5 equals x by way of simplification. There. And of course, we don't usually write it this way. X must be equal to negative 5. And this is by way of, by the reason, distributive up. You can call this symmetric. Yes, symmetric. There. All right, symmetric property. And we just have the solution. And this is the conclusion. And that means proven. There. Next, we shall proceed to the final example, the 5th example for our lesson. We shall be able to get that from the same screen. And that should be number 5. Okay, here's number 5. If negative 4 times the quantity x minus 2, close parentheses, divided by 3 equals 8, prove x is equivalent to negative 4. This is number 5. All right, we shall prove this, and we shall copy again the problem from the previous screen. Okay, this one. We're doing number 5. Okay, so let me scroll to the 5th one. And we have 5 lecture examples. Okay, so let me go back to where we're doing our solution. Okay, that must be this one. Okay, now we shall remove number 4 here. Okay, we still have number 4 over here. Okay, we shall replace it with the number 5. Okay, here's number 5. Yeah. If negative 4 times the quantity x minus 2, close parentheses, divided by 3 equals 8, prove x equals to negative 4. Okay, here is the conclusion. We shall prove x is equal to negative 4. Our solution will be consisting of statements and reasons. There, that 2-column proof. And we start with the first number. Okay, of course, we shall start with the given. And let me just copy and paste that. Okay, that will be over here. And this must be given. There. And for the second statement, all right, we shall try to simplify this right away. All right, if we wish to remove this 3, then we can apply multiplication. Okay, we can apply multiplication. So multiplying both sides by the number 3 cancels this out. Okay, a denominator of the 3. Remember, this symbol is divide. Okay, so if we only use 3 times negative 4 times the quantity x minus 2, over 3 is equal to, we also multiply the right side by 3. There, asterisk means multiplication, of course. So we can actually simplify this to something like negative 4 times the quantity x minus 2 equals to 24, something like that, without the 3. And we shall have something like, in our reason, this will be multiplication property. There. And so this number 3 here cancels out with this number 3. Our left side will just be negative 4 times the quantity x minus 2. And this is equal to 24, yes. And that will be by way of simplification. There. And so we can now just divide by the negative 4 this time, because 24 is divisible by the 4. So we can have division right here. And this is x minus 2. We are going to divide this by negative 4. And the right side is also divided by negative 4. And so we're going to have something like division property over here. And of course, we cancel out negative 4 and negative 4. We only have now x minus 2 at the left side. And the right side is, of course, negative 6. There. And this is by way of simplification. There. Now we shall apply addition property for this one, this particular line. X minus 2, we shall add 2, and is equal to negative 6, we add 2 also. This is now addition property. There. And left side becomes x, and the right side is negative 4. And we have the conclusion. Okay, we have proven the required statement. Okay, so this is now by way of combining like terms. There. Okay, so this is proven, and this is how to do proving in geometry or algebra. In our next session, we're going to have geometric figures and also the same way of proving. It will have statements and reasons. For now, I will end up our discussion over here. We shall continue with the geometric figures next time with the same statements and reasons procedure. All right, bye-bye.